Hey y'all, in this video I'm going to review the central limit theorem, which was when we talked about the distribution of sample means. It looks a lot like um, just the regular normal model, but there is a specific difference that we need to pay attention to. So I chose this problem from 7.4, which you could check out if you still have it, or you can go onto Canvas and find it. Or again, you could just take a look at it right here and use some blank paper to work through it. But part of this question is going to be like using the regular normal model. And then the second part is going to be using this central limit theorem, which has a slight adjustment, but an important adjustment in order to come to a conclusion. I always like to start and document what it is that I'm given. And so we're given an average amount of time spent working on the weekends. So we'll call that Greek letter mu, average of 7.93. And we have a standard deviation, Greek letter sigma, lowercase sigma of 0.8. And so the first question says, find the probability that an individual, so we're talking about one worker, the probability they work fewer than 8 hours. So fewer, that's going to be like a less than situation. So less than 8 hours. And so this is like if you watch the previous video for 7.3 review, a problem where we have a normal model. And so we'll draw a normal model. Again, it doesn't have to be beautiful. Mine certainly never is. Our mean goes in the middle. And this axis, this horizontal axis, is going to represent like hours worked by one person. You don't necessarily have to write that, but it's gonna be a good difference between part B. So these are all representing hours worked by one person or one worker. Our standard deviation is going to be that standard deviation up here that we were given. And then we want to know, what is the probability that this randomly selected individual works less than 8 hours? Well, we'll put 8 hours on here because that's an hours worked uh, axis. So we could put it anywhere. It doesn't have to be perfect. It just has to be useful to us. 8 hours, and we want to know less than 8 hours. So that's to the left. And if you didn't watch the last video, that's okay. I'll do it here. We're going to go in and tell the calculator we have a normal distribution. So it knows the shape of the distribution that we have. We're going to tell it what's in the middle. Well, that's our mean, 7.93. We're going to tell it what's our standard deviation, because 3 standard deviations to the right and 3 standard deviations to the left is going to encompass almost all of our data points. So that's that standard deviation we were given. And then we need to tell it the minimum and the maximum. And remember that minimum is what is on the left of the area you colored in. Maximum is what is on the right. Well, in this case, on the right is that 8 hours worked. And on the left is negative infinity, because this thing technically goes on forever and collects a little bit fractional, almost meaningless amounts of probability as we get to the end. And so we can go put that into Desmos, which I will do. And I will clear out my previous problem from the last video. So we had, and I'll have to go, we had a mean of 7.93 and a standard deviation of 0.8. And then we're going to click that CDF. I'm going to zoom in so I can see what it looks like. My maximum was 8. My minimum was negative infinity. And it looks like just about half of the area, which is what this says. So 0.5349. All right. And I said in the last video Sorry, 0.5349. I'm testing out a new program here. So um, I'm getting used to all the tools and making it work. So about 53%, maybe close to 54% of the workers would work less than 8 hours on the weekend. So now let's look at what is the difference uh, when I am looking at part B. Well, this says we take a sample of 40 construction workers. When we take that sample, we want to know what's the probability that the mean of that sample is less than 8 hours. So we're still talking about less than 8 hours. But now we're not just talking about one construction worker. We're talking about 40 construction workers. And what's the probability that if we add up all of their time worked on the weekend and divided it by 40, what's the probability that that average number of hours worked is less than 8? So we're not just looking at one person now, we're looking at an average of 8 workers. And so when I draw my picture, it's still going to be a normal model. Again, not beautiful. We still have an average number of hours worked is 7.93. But now we're not going to have a standard deviation of zero point 0.8. We are going to have a standard error of our standard deviation divided by the square root of our sample, because our standard error is going to change depending on how many workers we sample. So this time we had 40 and our standard error was 0.8. So I'm going to do 0.8 over root 40. We do not have to make that calculation. We can type this right into Desmos. This axis is no longer going to be hours worked for one worker. It's going to be average hours worked. And we'll still put 8 over here somewhere. We still want to know less than 8. So these pictures look very similar, almost exactly the same, except what we are considering the x-axis. Before it was hours worked for one worker. This time it's average hours worked for 40 people. I'm still looking for this area. When I go to Desmos, it's largely going to be the same input. The only thing that's going to change is I'm not just going to type in 0.8 where the standard deviation goes. I'm going to type in this 0.8 divided by square root of 40. And we can just type it in just like that. So if you have it still pulled up on Desmos, all we have to go do is divide that 8 by the square root of 40. And you can see that our picture changed because we no longer have the same standard deviation. And also our area changed. So it went from close to 55, between 54 and 55, to 71% of the area. So my answer down here would be, we could say 0.71, or we could say 71%. And so you can see there is a difference. The first one is when we're talking about individual data points. The second one is when we're talking about a sample average. So something to look out for when you're doing these normal model questions and practicing and reviewing for the final is, are they asking about one individual or are they asking about a sample mean? If they're asking about a sample mean, the change you have to make is you need to do this population standard deviation divided by the square root of n, the sample size. In this case, it was 40. I probably should have written n right here, but it still works. You should work through the practice problems that look like these. You should ask for help if you need it. You should check your answers with my answer key, and you should take your time. And good luck.